All right, we're going to be finding the inverse of natural logarithmic functions. So let's go ahead and take a look at this first one here. This particular problem, we're going to start out just like we started out all the rest when we're trying to find the inverse of a function. And we want to switch the x and the y. So I'm going to go over here and I'm going to change this f of x simply to a y. And this is going to be equal to, I'm going to bring down the rest of this, ln, which stands for a natural log with a base of e, times x minus 8 plus 4. Now, once we finished writing it with our y and our x, right, we're going to go ahead and swap them. And remember, x is simply just going to move over to the left and take the place of y, and y is going to move over to the right and take the place of x. Therefore, when I rewrite this, it's simply going to be x is equal to ln times y minus 8 plus 4. So all we did at this point, we just swapped the x and the y. Alright, and now we're going to go to our next step. After we swapped it, which is step 2, we're going to use inverse operations to move the constant. So notice we have this constant over here to the right of our parenthesis where it says plus 4. So I want to move that to the left side of the equation. So I'm going to subtract it because here they're adding it, and that way it cancels out and becomes 0. But I got to remember that I also have to subtract it on the left side as well so that we can keep this equation balanced. So let's go ahead and we're going to rewrite this real quick. I now have x minus 4 is equal to ln times y minus 8. So notice now we have a little bit less stuff on the right, because our goal is to isolate the y, and in the end we're going to have y equals something. So I'm going to move this up just a little bit. Notice our step 3 says convert to an exponent with base e. Now, you heard me say base e right in the beginning of the video, and that's because anytime you see this ln, this natural log, it always has a base of e. And what I mean by that is if I was over here, if I wrote ln in, my base would be e. And this is important because we're going to convert this to an exponent, and we need to know what the base is if we're going to write an exponent. Because an exponent has a base, it has an exponent, right? Also sometimes referred to as the power of it, and then it has an answer. So we're going to look at this and kind of break this down into those 3 different parts: an exponent, the base of the base, and our answer. So when it comes to the exponent, that's going to be what this is sitting here equal to. So I'm going to circle it, and just over to the side, I'm just going to write a note. I'm going to write this is our exponent. In other words, it's going to be written very small up at the top right of the base. Now, even though ln doesn't show a base, it's implied that it's e. Anytime you see ln and there's not a number there, right, just know that ln has a base of e. So I'm going to put an e down here, and I'm going to circle it. That right there is going to be our base. And then we need to go ahead and know our answer, right? Because we can see what to put on the other side of the equal sign. And when it comes to the answer, that's actually going to be this y minus 8. So I'm just going to circle what's inside of here, inside the parentheses. Put me a little arrow out, and I'm going to say that that is my answer. So let's go ahead and convert this to an exponent now. Now our base is e, so I'm going to start by writing my base. So I'm going to write e right here. Now the exponent for e, right, we're going to have a power up here, so I'm going to put parentheses because we have an expression that we're going to put in for the exponent. And my exponent is actually going to be x minus 4. So I'm going to put in x minus 4. Close parenthesis. So far we have written our base. We have written our exponent in place. And now we're going to go ahead and we're going to set that equal to our answer. So I'm going to put equals, and then y minus 8. So now this is officially an exponent, right? Because every exponent has a base, and this is a base of e. It has an exponent, or what we call a power, right, up here, that superscript, which is x minus 4. And it has an answer, which in this case the answer was y minus 8. Notice that's what's inside of the parentheses in front of the natural log. And so we wrote that right here, our answer, y minus 8. So now that I've got all these written out, we're going to continue working on it to move everything away from the y to isolate it. So I'm going to move it up just a little bit. And notice right here it says now use inverse operations to move the constant. So once again we're going to move this constant over. So this is a negative 8. So what I'm going to do is add 8. And that'll zero it out, right? Makes a 0 set. I'm also going to add 8 to the left side, because we have to keep this equation balanced. Now if I were to go ahead and rewrite this, it would be rewritten like this. I'll have my e to the power of x minus 4 and now we have plus 8, so I'm going to go ahead and add an 8 to it. Plus 8 is equal to y, which is all we had left on the right side of the equation. So we are almost done at this point, but what we want to do now is we want to go ahead and do step 5, which is rewrite the equation with y on the left. So imagine, right, it's a pancake, we're scooping it up and we're just flipping it over. So I'm going to move y over here, so I have y is equal to e to the power of x minus 4 plus 8. Now our final step with this is we want to go ahead and indicate that this is the inverse function of something that we started with. So we're going to do step 6, which is write the final answer using function notation indicating it is an inverse function. The way we indicate that is this y is going to be written as f of x to a negative 1. And we're going to say equals e to the power of x minus 4 plus 8. And then we are done. This is the final answer.